morning. Today I will discuss about psychrometry. So psychrometry is a subject which deals with the behavior of moist air. So study of moist air is known as psychrometry. So the study of moist air is known as psychrometry. Moist air indicates it's a mixture of dry air and water vapor. So the behavior of atmospheric air is referred by a subject called as psychrometry, and the properties of moist air are known as psychrometric properties. Psychrometric properties. So it is very important to know psychrometric properties before moving to the air current system, which will be addressed in the next class, right? So there are two laws we need to know before moving to the psychrometric properties. One is called as Dalton's law. It deals with partial pressures of elements of air. The Dalton's law states that the total pressure exerted by the moist air is equal to the algebraic sum of individual pressures acted by the elements. For example, there will be two elements. So dry air, its partial pressure PA, and there is another element called as water vapor, its partial pressure is PB. Then the total pressure acted by the individual elements must be equal to P. So that is, P is given as PA plus PB, where P is called as total pressure of the given moist air, where PA is called as the pressure exerted by the dry air elements, and PB is called as partial pressure exerted by the water vapor. So the Dalton's law states that the total pressure exerted by the given moist air at a given temperature is equal to the algebraic sum of partial pressure exerted by the individual elements. In similar manner, there is another law called as Avogadro's law. So it deals with partial volumes. Avogadro's law deals with partial volumes. So it gives as the total volume occupied by the moist air is equal to the algebraic sum of individual volumes occupied by the elements. So it is called as Avogadro's law. So just now we discussed about two laws. One is called as Dalton's law, which deals with partial pressure of individual elements, which is equal to the total pressure exerted by the moist air. Then another one is called Avogadro's law, which deals with the partial volumes. The volume occupied by the given moist air is equal to the sum of individual volumes acted by the elements. So those are called as Avogadro's law and Dalton's law. Now let us discuss about psychrometric properties. There are 7 psychrometric properties. So one is called as dBT, which stands for dry bulk temperature. And it is measured in degrees centigrade. What do you mean by dry bulk temperature? It is the temperature recorded by a normal thermometer or simple thermometer of the air. So the temperature recorded by simple thermometer, generally it is referred as dry bulb temperature, right? So you know thermometer construction details. It contains a simple glass tube, having pre-calibrated scale in degree Fahrenheit, and internally there is a fluid called mercury. It is called sensing fluid. With respect to the ambient conditions, so the level will rises, and we can read the temperature in degree Fahrenheit, right? It is called dry bulb temperature. So the temperature recorded by simple thermometer, generally called as dry bulb temperature, and it is expressed in degree centigrade. Mostly it is indicated as dBT. Whatever the temperature value you are referring in our day-to-day life, it is nothing but dry bulb temperature. Another property called as WPT, which stands for wet bulb temperature. What do you mean by wet bulb temperature? The temperature recorded by a ordinary thermometer when the sensing tip is covered with wet cloth or wet container, right? What do you mean by wet bulb temperature means? It is the temperature recorded by a thermometer whose sensing tip is covered with wet cloth or wet container. So whenever the sensing tip is placed in the wet cloth or wet container, whatever the temperature it is recorded, it is called as wet bulb temperature. Then there is an instrument called as sling psychrometer. There is an instrument called as sling psychrometer where it can record simultaneously WBT, DBT at a time for the given eye. If you want to measure dry bulb temperature, wet bulb temperature at a time, generally there is a device is used which is called as sling psychrometer. So this is most commonly used to measure dry bulb temperature and wet bulb temperature of the air. So the units of wet bulb temperature is remain same, which is degree centigrade. Then another property called as dew point temperature. It is also measured in terms of degree centigrade. So dPT indicates dew point temperature. What do you mean by dew point temperature? It is the temperature at which water vapor starts condensing. So everybody knows that atmospheric air is a mixture of dry air plus water vapor. This water vapor starts condensing when it reaches certain temperature. That respective temperature is called as dew point temperature. So it is the temperature at which water vapor starts condensing. So whenever the air starts condensing, then it reaches dew point temperature. So dew point temperature is nothing but, so the atmospheric air contains water vapor. At particular temperature, whenever atmospheric air is temperature drops, automatically water vapor is converted to liquid. That respective temperature is called as dew point temperature. Another property of psychrometry which is very important, so it is called as humidity ratio. Or it is also called as specific humidity. And it is represented as omega. Specific humidity, it is represented as omega. What do you mean by humidity ratio or specific humidity means? It is the ratio of mass of water vapor to the mass of air when it is mass of dry air. So the ratio of mass of water vapor to the mass of dry air in the given moist state, that ratio is called as specific humidity or humidity ratio, and it is expressed in terms of kg of water vapor to the kg of dry air. This is the unit, kg of water vapor to the kg of dry air. So the ratio of mass of water vapor to the mass of dry air for the given moist air is called as humidity or humidity ratio. We in general, atmospheric air mostly contain dry air concentration rather than the water vapor content. So if you take the numerator is very lower value and compared to the denominator, automatically the value obtained from the given moist air of omega is very small in terms of fractionals. So we know the characteristic gas equation, and if it is applied for air, then PA VA equal to MA RA TA. It is gas equation applied for dry air. Similarly, if you apply gas equation for the water vapor, then PV VV equal to MV RV TV. It is water vapor. Then from the gas equation, if I write MA by MV, MA by MV, then the equation is PA VA by RA TA divided by PV VV by RV TV. RV TV. So for a given temperature, the temperature TA equal to temperature of water vapor. Then these two getting cancelled, right? Then we are having R equal to RU by M. R equal to RU by M, where R is called as characteristic gas constant and U is called as universal gas constant and M is called as molecular weight of the element. For air, if I write RA, it is RU by MA. For water vapor, RV equal to RU by MV, right? So this can be rewritten as, even for volume of air or volume of water vapor, these are also same. So VA equal to VV. As a result, these two are getting cancelled. Then we are having equation as PA RV by RA TV. So that is called as omega value, where this RV characteristic gas constant for water vapor, RA characteristic gas constant for dry air can be substituted here. So omega is given as RV into PA divided by RA into PV. So instead of writing RV, I will write RU by RV by MV into PA divided by RA. It is RU by MA into PV. So this universal gas constant getting cancelled, then it is MA into PA by MV into PV. So if you simplify, we will get it is around MA 18.0166